The long division algorithm really makes no sense to students. So for instance, when we start with this number, which is the highest number we would deal with in grade 6 in the Ontario school system, first we would ask how many times does 17 go into 1? And we would say it doesn't. And then we would say how many times does 17 go into 12? And it doesn't. And then we would say how many times does 17 go into 124? And then we would get started in our little routine. Except that every one of those statements is mathematically wrong. This is not the number 1. This is the number 1,000. Are there groups of 17 in 1,000? Yes, quite a few. Are there groups of 17 to 1,200? Yes, even more. So in fact, what we do to teach this algorithm is we lie about place value, and then we wonder why kids are confused. But once we get past that, we still have other issues. So now if we finally decide how many times does 17 go into 124, it will go 7 times. And when we multiply, it comes out to 119. And we have a remainder of 5. And then we say, now we have to bring down this number. But what is a bring down? What mathematical term is bring down? What in fact is happening? In fact, what is happening is we're subtracting. And what we're subtracting is in fact 1,245 minus 1,195. Because in fact, here is a 0. And the reason that's a 0 is because this number is not 7, it is 70. And 70 times 17 is 1,190. So now, when we finally get to this stage, things actually kind of make sense a little bit, because we can say that there are 3 groups of 17 in 55, and that is actually accurate, and that is 51 with a remainder of 4. In fact, a much better way of doing this is that one of the traditional algorithms from Europe. 17, 1,245. Well, how many groups could I take out? Well, I for sure could take out 10 groups of 17, which is 170, which is nice and easy to figure out. That's 5, that's 7. Can I take another group of 10? Yeah, I can. And I'm left with 905. In fact, if I'm looking at this, I can actually take out 20 groups of 17 and get 340. And again, subtract here, 6. I can take out another group of 20. I can't take any more groups of 20, but I can take another group of 10. And I'm back to where I was up above. 3. Remainder 4. 20, 40, 50, 60, 73. 73. Remainder 4. Just like before, but it actually makes sense to the students. And in an era where I can do either of these with a calculator way faster, if I want kids to understand, this is the algorithm that I want them to use.